So yesterday we worked on this thing where we created our own mini DSPy module, which is an AI module that solves problems. Okay, so we call, and the way we do it is through a signature, blah, 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 problem solving, 2 inputs, 2 outputs, if you remember, problem and cases, 2 outputs, solution and test. In both cases, the outputs are code. The reason why we had 2 outputs is because we wanted DSPy to also generate test code for the solution code, which sounds like something sane, right? You would like to automatically have AI also generate test code for you. Yeah, and it works. So let's go back to, let's go back to this simple problem. Okay, so we can ditch this one for now. So we have our problem solver, which is a DSPy module, and we want AI to solve the problem in this specific input, given these example test cases. In this case, it's a really, really basic coding problem. It's given an integer array num sorted, which is already sorted. Consider the number of unique elements to be k. Return number of unique elements. Okay, so pretty easy problem. Given a sorted array, find the number of unique elements. Let me run this again, because let's see if we can spot what's wrong here. Everything is nice in AI world, still using the NVIDIA model, which we run for free with the open router. I'm just gonna make a free account, generate an API key, doesn't cost you anything. Okay, and this thing is running, and it should also automatically save it to a solution folder. Come on. Interesting. So we got an error for DSPy history. Huh. Have not seen this one. What's going on here? Do we have DSPy? Did they update it or something? 304. Let's try that again. Do I get the okay, so let's debug this. So I need to stop here. Do I get the prediction right? I do get the prediction. Okay. Let's see. So if I do pred.solution, I think I also need .code here. But before that, what the heck is going on here with the DSPy inspect history n equals 1. Okay, so this works here. My pretty print is broken. Let's see what happened here. Char map can't encode. Okay, this has got to be a Python version thing, right? So I can just look this up. Char map code it can't encode. Oh, it's a Windows thing, for God's sake. This is totally a Windows thing. I see, so VS Code. A non-breaking hyphen to use limit character count. Default Windows char map. Okay, this sounds exactly. Both your Python and the VS Code terminal use UTF encoding. Set Python IO encoding. Okay, so I need this thing here then. Terminal. Okay, so let's go to the settings then. And what was it? Terminal integrated dev. No, env dot windows. Okay, and he wants to do Python IO encoding. Can I copy this? Okay, I can't copy that. Okay, and then he wants to restart VS Code. Okay. Restarting VS Code. Okay, again, UV run main. Interesting, this did not work. Terminal integrated env Windows. Python IO encoding. Do I have this? I do have it, okay. So this thing worked, but the whole thing doesn't work. Does it want the context here? Oh, I see. So with encoding, maybe it is as easy as this. Not really, right? Yeah, so I can't inspect DSPy history. I wonder why. How come it worked yesterday? Let me move this here. I need more help here. What's going on? Oh, this is not a good search query. Windows. Encoding is UTF-8. Is this a DSPy thing? Nah, it's not a DSPy thing. It's a Windows thingy. Okay, something is off here. How the heck did this part 1 work? Okay, part one does, what? Part one does work. Why does... Okay, well this is something else then, so I don't need this thing for sure. Because what we did yesterday obviously works, and then is it a different Python version that I have? I do have 3.14 here. Interesting. Do they have the same Pi project toml? They have exactly the same Pi project toml. Do I have to UV sync again? I'll bet you it's the problem. Do I have those weird characters? Let's see. Aha, okay. So what the, I have, okay, I know what's happening here. When I pasted this text, there's got to be some non-Unicode thing here. Because I pasted this from the LeetCode website. So actually, let me, let's see, is there an online Unicode sanitizer? Yeah, maybe there is. Because something is off with the strings here. So if I take this string, and then if I put it back, maybe it's sanitized now. No, it's not sanitized. Okay, is something weird happening in the prediction? So what am I predicting here? Print pred solution.code. Maybe some tabs or something. Test.code. And if I switch this to this other one and it magically works, what is, so if I switch this, yeah, this works. It's hard to tell what's different here, right? Because this is valid code, and then print test is probably also valid code. Well, this shows stuff is not that robust yet. Oh, is my annotation wrong? No, it's not wrong, right? Because it's list. Yeah, it's a list of lists on the inside. This seems fine. List of tuple list. Ah, wait. Oh, no, it's right for this one. Yeah, okay. Do I need a trailing new line here or something? Problem cases. No way I actually need that trailing new line. Oh my god. What? Okay, well, mystery solved. I don't know how to use... What? So if I do this... Yeah. Wild. Pretty wild. So that... Wow, this is pretty wild, actually. This may be worth filing. What the heck is even happening here? So if I don't have the trailing new line... I just don't have a trailing new line. That's it, right? Huh. And then this crashes, but if I do add a trailing new line, which is actually a new line, wild. Absolutely wild. How the heck did this work yesterday? So then print inputs problem. Yeah, there's just a trailing new line. It's got to be some tokenization issue that's happening behind the scenes, or I don't know what the heck is happening here. Huh. Python triple quote string trailing new line UTF-8 bug Windows. Windows typically uses the carriage return line feed OKRN, while Unix system default encoding. So if I do strip, it's gonna not work, right? You bet. Dot strip. Okay, so what is character U 2011? What the heck is this? U... Why am I seeing this? Unicode. Non-breaking hyphen. Looks like a regular prevents line breaks. Useful keeping compound words and numbers together across lines. Typed in Windows using all 2011. Damn. Oh, I see. So do I have to reconfigure to explicitly set the encoding in the script? You can use env vars. Okay, dude, if I have to do this just for this. No. Python, oh, okay, so Python on Windows, yeah, so we tried this. Could you set the environment Python UTF C57? Oh, so we have to set this. Okay. Damn, how the heck did I set how do I forgot how to set VS Code set environment variables. Okay, so what did they want me to do then? Let's set Python UTF-8 to 1. There's no way this works, right? So then if I terminal, new terminal, and it was echo env Python UTF-8 1 uv run main.py. Okay, finally. Okay. So then, yeah, it is a Windows thingy here, so I don't need the trailing new line. Okay, so Python is broken. This has nothing to do with UV, fortunately, but Python is broken on Windows. That is good to know. Okay. Are we done with messing around? Yes, we're done. So this is part 2, uv run main.py. So let's run this on our, again, so we have DSPy, we have a very basic problem, given an integer array nums, consider number of unique, find number of unique elements. Let's run this. Now let's check out the solution it generated. Okay, so it generated the function unique elements. And here's one problem now. The problem is that I have a solution code, but the test code is not going to run now. So if I try to run solution test, undefined unique elements. Okay, so the AI, this is already a sort of a sharp edge in DSPy. It's kind of related to what I wanted to fix today, but not really. It's because the AI was not smart enough to import or to reuse one output in another. And for Python, that's because in this specific case, it doesn't know the files are placed in the same folder. So this is fixable by hand, because you can say from solution import unique elements, and I think it has to be from dot solution. Okay, so from the same folder import unique elements. Okay, so now I as a human, sorry, I have to run this now from the same folder, so I can run uv run test. No, maybe like this. Yeah, so actually this probably works. This is still finicky, but it works though, because Python modules, they have visibility if they're in the same folder. Let's try AI again. So if I run main, let's try to generate again. Because AI is non-deterministic, in this case it's the same thing again, because I want to elicit something else. This is a good chance to talk about temperature. So DSPy language model, temperature, float none. So let's set a temperature of 1, something that encourages a bit of randomness. Maybe we'll get a different code. We did got a different code, and there's other issues now. Well, no, the same issue. Now the model changed the name of the function. It's now called find unique count, but again, it's using it in the test without importing the function. Let's try again. Same thing. Oh, I think I know what's happening. So DSPy is caching, right? So cache false. Yeah, okay. Sorry, I know what was going on. So because it's caching, we'll never see, we'll always see exactly the same output. But now that we don't cache, we can actually regenerate this. Okay, again, a different variation of the same solution. Now it reads count unique. Same thing, it tries to use this function without importing it. So can we systematically fix this? But I want to elicit something else though. This is not the sharp edge I was going for. Let me try again. Aha, got it. Okay, here it is. So this is what we got yesterday too. Now, apparently it doesn't happen consistently. Okay, we're good. So we found two issues, right? So one is related to the model. When you ask a model to do two things in order, it does the first thing right in solution. But then if the second output depends on the first, it either doesn't know how to properly reuse code from the first output, which is the missing import thing, but something else happens now. If I run the test now, this one actually does work. So sometimes it does work, but there's actually a way bigger problem here, which is exactly what I wanted to show. Maybe we'll address both. Yeah. Both with two different solutions or a composite solution. why does this test code work? There's mega trickery happening here. If you look at the solution and the test, there's a repeat of the function definition, which is not good at all. Okay, this is like, and you probably know this from high school or middle school, but at least in math, or maybe in like intro to programming or something, they always give you homework. Let me write it here. So let's say your teacher gives you homework like this, right? So he gives you given blah, blah, blah. So this is what DSPy would call the inputs, okay? Then your teacher says find, find A something, B something, C something. Now what happens is, for educational purposes, a lot of times when you used to, so this is a DSPy output, and what used to happen to you in high school, I'll bet, is that A, B, and C were sort of related. So once you solved homework subproblem A, most likely you would have reused that result in B, right? So B would have most likely reused result from A. Same thing in C. Most likely reuse result from A, possibly from B, right? Because homework was generally incremental. If you had the same problem with the same inputs in the same setting, you were asked many things. They're usually in order, right? It's very rare, and you can find this at the IMO or even in competitive coding problems. It's pretty rare to, actually it's probably never happens if somebody that knows what they're doing writes the problem. You never get asked questions in reverse, right? Like you don't get asked the harder question first, then a subset of it second, because that doesn't make any sense. First you get asked about a special case, and then you're supposed to reuse that result to generalize. That's what you would do as a human, right? If you would see a homework with 3 points, you would think, okay, let me solve point A. Then when I think about how I solve point B, maybe I can reuse something from point A. Maybe not. That's not a guarantee though, all right? Sometimes the points can be completely independent. The thing is, this happens here for this DSPy program for sure. Because now we give a homework to the AI and we tell the AI to solve 2 things in order. Give me some code that is a solution to the problem, and give me some test code that tests the solution to the problem. So then for us humans, it's pretty obvious that you should not do the test first. That would be kind of dumb, right? First you would solve it and then you would write a test for the solution. The first part works with AI, right? Remember, this AI is also autoregressive, so in some sense these problems actually get solved in the order they appear here. If I flip the fields here, this is me writing bad DSPy, right? Like if I ask an AI model to output these 2 things, this will change how they appear in the requested outputs in that order. Kind of doesn't make sense. So the order I have here is good, okay? So first I ask for a solution. The AI complies, but then I ask for test code for the solution. Unfortunately, the AI doesn't systematically comply. And we saw this fail twice in 2 different ways, right? So let me actually make a new folder and let's call this solution fail redefine. Okay, so one way this fails is, here we go. It's when the AI redefines the function in the test code. In this case, it happens that they're the same. But what if there's 2 problems with this? One is, what if they're not? And what if the function in solution was wrong, okay? So then if my function, let's say I had a function in solution which returns banana all the time. What is gonna happen when I run the test in the, so if I go in UV run solution fail redefine test, this still passes because I didn't touch this. And this is the only function that's being tested, which happens to be redefined here. And this is really bad, okay? Because now the AI sort of tricked me because it's generating a test, but not for the file here. The second type of failure we saw, if I run the main again, maybe we'll get lucky and we'll get it again, is kind of a more basic one. It's when it's strictly related to Python and it has to do with, oh, see, here's, okay. So here's a nice one. Here it failed. Oh no, sorry. Okay, so test. Oh yeah, here's the second failure. Okay, so let's log this too. So we can do solution fail unknown. So the other way to fail is when the AI just doesn't know Python or doesn't have enough information to know that these two will be saved in files in the same folder. Okay, so then if I try to run UV solution fail unknown test, this is not going to run at all. Now the fix to both of these is the same by hand. Okay, well, ish. In the unknown case, the fix is easy. Just from solution import unique elements, but assuming the function in solution.py is named the same. How do I know this? I can't know this because this is AI, right? So now if I try to run this, this works. But this assuming here is not trivial because that would have to be verified. Okay, so I don't know what the AI did here because I didn't parse the code output, and DSPy doesn't parse code for us. That's a bit out of scope. But still, maybe I can write a tool that automatically writes this, and then using runtime feedback, the AI will sort of figure out that the symbol is missing and it'll try to regenerate it. The fix for the redefine is a bit trickier though. I can't just import from here. Okay, so let's see what happens in the redefine. So in the redefine, I have a unique count in another file, but if I do this, this is gonna work, okay, but it's not really gonna work. So let's see, solution, fail, redefine, test. Okay, this runs. What's the catch though? The catch is still, if I, this doesn't actually do anything. If I return banana all the time, all the tests still pass. That's because of how Python works, right? So this beats the import. Like this overwrites the import. So now as a human, there is a cheekier solution. It's, okay, what if I magically put this import here after the define? Okay, now it's gonna work. Now my test failed because the function is wrong. So if I switch back to the original function, this is actually the thing being tested. Okay. But here's what I want to do today. In the time we spent 40 minutes fiddling with Windows UTF-8 stuff, but in the remaining time, my question is, how do I, so let's say I don't want to do stuff by hand. I hate coding, okay? And I don't even want to parse code. I just want the AI to generate this import and not leak logic. Okay, so another name I have for this phenomenon is called leaky logic, okay? Because it's leaking logic in the test code. How do I fix this? Okay, well, and how do I fix this can I extend DSPy or in a more generic way? So let's fix it manually first through prompting. Okay, so I kind of want to do it through prompting, but I don't want to prompt by hand. But first, let's prompt by hand, okay? So what I can do is, I can tell the model, do not, and I'm going to be very assertive here, do not leak or redefine any logical implementation in the test code. Okay. Instead, reuse the function from solution. Let's see what this does. This should mitigate the redefine problem, but we may still have the missing import problem. But if I just add one more instruction, that'll mitigate that too. Okay, so let's run it with this system prompt now, which strongly asserts for the, now it also depends if models listen to us, and generally more powerful models. Okay, so we have a solution, test. Okay, we're not seeing that. Let's try to run it 5 times. Okay, let's see if, are we ever gonna leak logic? Nope, we're not leaking logic the second time. Of course, you can test this more rigorously. It would be nice if I'll probably have to switch to Linux to run a systematic experiment. Disobeyed here. Okay, so prompting is not enough here. At least this prompting by hand was not explicit enough, because the model did a sort of a weird function in function. And now I'm curious to debug the history here, what happened. So the model did some sort of weird function in function thingy, still is leaking logic, right? Because, yep, there it is. This should not be here. But maybe that's because it doesn't have enough import info, okay? But this is a good time to also debug the history. So let's see what happened here. Oh, I see. What's happening here is that I don't know how to write triple quotes, my bad. So this is all... Okay, sorry. So actually, well, this is pretty dumb, because it seems that yeah, so, okay, so in DSPy you have to use the triple quote docstring. It doesn't work with separated new lines. Or am I seeing some weird sort of thingy here? No, this should be fine now. Okay. So now, so what was happening is that these 3 lines of instructions were not even being counted at all. Where, okay, now they are. Okay, so in the Turing do not leak. Okay, so now let's try to test code again. Okay, so no more leaky logic. And you know, let's make it even closer to what it was then. Let's have the prompt be like this, right? Because before it was only like 1 line. So now we just need you're an expert in solving algorithmic problems using Python. Do not leak. Instead, reuse the function from solution. Okay, and the fields have their own descriptions. Let's see, are we leaking logic? We're not leaking logic once. Aha, we're not leaking logic, but the model already is smart enough to figure out there's a missing import here. So the solution is good. The test is also doesn't redefine this. Okay, we even got the import as a comment. Okay, let's run it again. Again, no leaky logic, but no import either. I want to see it 5 times in a row. We got a wrapper here, whatever. Oh, this is the dash thingy that was the Windows UTF-8. Oh my God, okay. This is the whatever line breaking dash or whatever U2011 Unicode character is. Okay, no leaky logic, 4 times in a row. Well, guess what? 5th time. What are you making? I am using this library called DSPy, which is like a basic AI module library. If you're not familiar with it, it's pretty neat. It's sort of this framework for building AI modules that do certain tasks. And what we're working on is a problem-solving AI module which takes 2 inputs and has 2 outputs. And behind the scenes, it calls a large language model to solve, we call it a problem solver because it tries to solve lead code style problems. So it takes a problem description in natural language and some numerical examples, cases, which are expected inputs and outputs. And the job of this AI module is to output Python code that solves the problem and also test code that tests if the solution is right. And this is pretty much all it is. It's like in whatever this is, in 60 lines, you can have a 30 billion open source model, which you can also run for free. You basically have your own lead code solver now, and at inference, you can just change the problem to whatever you want it to be. So right now we're testing it on this very basic problem. Given an integer array, consider number of unique elements, return the number of unique elements in a sorted array of integers, which is really, really easy. But we're already, what I want to do is a bit more involved because there's already problems. So let's go back to the thing here. So it's a module with 2 outputs, the solution and the test code. The solution looks okay, pretty much, right? This is AI generated Python code that solves the problem. In this case, the problem was to count. Yeah, DSPy is pretty good. Yeah, you should check it out if you're into AI. Yeah, thanks for stopping by. You can just leave this in the background or feel free to ask more questions. So the issue that we have is a bit more subtle because even for this very basic problem, okay, so the problem is very, very easy. It's the problem instance we gave to this module is to count the number of unique elements in an array. So if I look at the Python code in the solution and output, and this is AI output, it's very, very basic, right? You just walk through the elements, and because they're sorted, if the current one is not equal to the past one, then it's a unique one, that's it. The problem we have is that the test code doesn't import this function. It redefines it. So there's 2 ways it fails. It either redefines it, which happens pretty rarely, and this is kind of what I wanted to avoid. Or more commonly, because I didn't give the AI, because it's not really agentic AI. If I try to regenerate this, I didn't give the AI enough info about how these files are placed on disk. Okay, so the more common case is this. So, okay, so this solution is valid, right? So it's the length of the set of nums. It's a really cheesy solution, but this is still counting number of unique elements. The problem is this test code doesn't work though, because if I try to run it, so what we do is we place both of these files in the same folder called solution, but in separate files. So if I try to run the test code, the AI did not know how to import, okay? And no, I kind of work on this. Yeah, I'm familiar with DSPy before, but I'm trying to do some things from scratch here, more basic stuff. But it's not my first experience with DSPy, although it's supposed to be really easy. It's supposed to allow you to write AI modules through these signatures, where you just give... Okay, so let's look at the signature a bit, because this is a chance to sort of try to fix this test code. So what I told the AI to do here, I just gave it a very basic description. You are an expert in solving algorithmic problems using Python. That's it. This is all the prompting I'm doing, because the goal of DSPy is to template all this for you. And then I try to mitigate, do not leak or redefine any logical implementation in the test code. Instead, reuse the function from solution. But still, this is not enough info, because the AI doesn't know those files are in the same folder. So now I can type a more explicit instruction here to reuse the function from solution in test. Just use the import statement from solution import, and I don't know what this is called, but I'm just going to call it function name. Okay, so now if I try to run this again, I'm pretty sure the AI is gonna nail this one now. But this is still not how I want to solve this, because I'll show you why. There's a software scalability problem here. Okay, let's see. So it finished generating, it placed them here. So again, the solution code itself is pretty basic. It looks correct. What is the test code? Oh, there we go. The test code worked now. Okay, so now we avoided leaky logic, because now the test code actually imports from this file by knowing, because we told the AI they're placed in the same folder. Okay, so this is pretty neat. Now if I run solution test, it failed because, let's see what happens here. Failed on 1146. This is definitely 5 unique numbers. The function is wrong then, right? So let's see what's happening here. Oh yeah, because it's a list of lists here. Okay, so I'm definitely confusing the AI with these inputs here. List, tuple, list of ints. Okay, this is still my fault. This is still user fault, because my signatures is still too convoluted here. So the problem description is a string. This one's pretty basic. Description of the problem to be solved. The problem is the cases have this complicated format, which I made up yesterday. So it's supposed to be a list of tuples, and each tuple is a list of all possible inputs, and each input could be a list. So it's list, integer, same for the outputs. We need to simplify this for sure. Yeah, so it becomes tricky to handle arbitrary number of inputs, right? So let's cut down the list from here. So we're gonna encode the assumption that the function only has one input and one output, and they can be lists, right? In this case, for this, the output has a single element because it's a number, and the input is the list of numbers to work on. So this restricts the problem space a bit the AI can solve, because now it's not going to be that easy to generate functions with two inputs. Okay, let's try again. This should all right, let's see what it did here. So solution, okay, to do test. Okay, so it used the unit test, it used the import, again, pretty good. So now the AI knows how to import, and if I try to run solution test, okay, now we get a pass because I simplified the API. Let's try again to regenerate. Okay, this looks okay. Let's try to run the test. Yeah, everything good. No assert, no failure. So again, we have the import here because we told the AI to do the import. Let's try one more time. Again, we have a working test, no leaky logic because we have from solution. Okay, so this kind of seems to solve the problem. Now we have reliable test code generation too, which is a whole different beast, right? Because we have the solution, and now we have a way to also test it automatically, and we can ensure that there's no duplicate code, like the test code doesn't redefine the solution again. Here's the problem though. This is not the DSPy native way to do it, and it doesn't scale with many outputs. So here's the thing. What if I want the AI to output even more things, okay? So for example, what if I want to output a complexity, which is also code? So this is gonna be, I'm gonna ask the AI to output 3 things now. And this will be code that measures the runtime of the solution. Actually, let's ask the AI to do 4 things. Let's call this time complexity, and let's have memory complexity, which is another Python code, another output field, and we want this to be, we want the AI to output some code that measures the memory usage of the solution. So what the heck am I gonna do now? Because I wrote the prompt here, which only says to reuse the function from solution in test. Just use the import statement. But is this generic enough? Not really, because now I'll have to add, see, and I also said here, do not leak or redefine any logic combination in the test code. Actually, let's see if there's leaking logic here. It'd be really nice if there is. So then let's also write this thingy here. So with open solution runtime.py. Okay, so we want to write the print time complexity, right? Dot code. Yeah, and then we also want to write the memory profiling code. Okay, so let's run this with 4 outputs. I'm curious to see if there's any leaky logic. Even if there isn't, it still doesn't, I still had to write that instruction by hand, and that's what we would like to avoid. Okay, so let's see what, so now the AI wrote the AI output 4 things, and DSPy extracts all the 4 pieces of code, and I write them to 4 different files. That's a better way to say it. So we have our solution, length of set, the trivial one. We have the test code, which does import. Aha, here it is. Very good. So here's the problem. Okay, perfect. Good. This is exactly what I was going for. So now the AI was dumb and it only followed my instructions just for test, because that's literally what I tell it to. Let me try this again. If this works again, this is awesome because it shows exactly what I wanted to fix. Yep, there we go. Perfect. So very good. So, okay, so we have the solution, another run. We have the test code, which is good because it imports, okay, and it actually runs. So if I run solution test, all test cases passed. But the AI did really nasty things it was not smart enough to reuse the solution for the memory and the runtime. Instead, it did really dumb things, which is like, it just hard-coded some things, and we kind of don't want, I was hoping that I would actually get something that measures and prints the runtime. But in any case, the bigger problem is that the solution is not imported at all. This is just based on sort of the AI seeing the solution and just hard coding the answer for it. So it's not really code. And that's because this use statement did not generalize. Okay, so I wrote this by hand for test and this keeps on working. Now I have a prompt scalability problem, because if I have to now write instructions for each of these, it's not gonna look nice. Okay, so now what the heck am I supposed to do? Do not leak or redefine any logical implementation in the test, time complexity, or memory complexity code. This is already hard to write because now in my mind I have to trace what is the relation between outputs. And same thing here, use the import statement, but not only in test. Reuse the function for solution in test, comma, time complexity, memory complexity, blah, blah, blah. So this is what DSPy is missing. This is exactly where I wanted to get. DSPy is missing a graph that tells it how to reuse, or that automatically writes prompts on how to reuse certain outputs for other ones. Let's call it an output relation graph. And this is what I wanted to implement, okay? Because I'm gonna go insane if I write these prompts here. Ideally, what I would like to do is just write this prompt. You're an expert in solving algorithmic problems in Python. And let's think about how do we want the user experience to look. It would be nice if each field would also take an argument depends on a list of other outputs. So this would be something like this. Okay, so we know the time complexity code depends on it, depends on the actual code in solution. We know the memory complexity code depends on it. This is also true for the test code, which we just solved by hand earlier. And let's say we want the test code to also exercise time complexity and memory complexity. Okay, so the way to think about it is, okay, I want the AI first and foremost to write a solution. Then I want to write two other library functions that reuse that solution and actually do things with it, like measure its time and memory. Then I want to write something else called a test code, which puts everything together and checks if the solution is right and measures complexity. Okay, so the field would be and runs measurements. Okay, so DSPy fields don't have this depends on field. And what would I like this to do? I would like this to automatically generate prompts for me. Okay, so it would be something like this. When generating a reuse, or let's say, so let's assume B depends on A. So then we'd like, DSPy calls these adapters, I think. We'd like to write a DSPy adapter that analyzes the graph between outputs and automatically generates the prompt like this. So the prompt should read, when generating B, reuse the code from A through. Let's solve the import problem too, because another thing that's missing is depends on, and there has to be a matching field imported. So let's have depends on be a dictionary or more a data class maybe, right? So let's have it be a dictionary. So it'll depend, the key will be what it depends on. So this will depend on solution. And then it'll be a sub-dictionary which says found at location. In this case, I want them to be in the same folder, right? So it'll be dot. This should be a path lib thingy, right? So we have to do from path lib import path. Okay, so this will be a path. So it's found here. And maybe it has some other quarks too, right? What else could you need to know? So you need to know what you depend on, which will be the key here. And for each of the dependents, you need some information about it. At the minimum, you already know what language it is because you can look at it. You can look at the field. So you know this is Python code. But I think in all programming languages, yeah, you need to write adapter. So we'll have to be careful here. This will have to be robust enough to work with relative imports in Python, and assuming it's a proper Python module, this should be fine. So maybe like this, right? So found that here. Okay, so then this also depends on this. And let's make this one even nastier. So let's say this is, so it depends on the solution. Okay, so let's have the folder structure be like this. So the solution and the test live at the same level, and then the time complexity and the memory complexity, they are found at, they live in a folder called measurements. Okay, so it'll be from here in the folder measurements. Now the thing is, this does delegate it to the user to write. Okay, so then we have to, it's our responsibility as a user now to write, to make sure we place them like this, because we have a solution and the test. The solution and the test live in the same folder, but we're also gonna have to create the nested folder. So we can make there's solution measurements exist okay is true. Okay, and then we're gonna have to run this here. So, oh, sorry, write this here, right? Because now okay, so we have the folder structure. Now the problem is, okay, through the import statement given appropriate for the language, for the code.language, and using found that. Okay, so now this is enough info to automatically write some prompts without us having to actually write them. So it allows us to think in terms of what code do we want the code to depend on. Okay, so now we need two things for this. First, we need custom DSPy fields. Okay, because if you look at input fields, they do take kwargs. Okay, so we can, let's see, DSPy field kwargs. Okay, maybe we don't need actually. Maybe the move kwargs, but then it doesn't allow arbitrary. Okay. If you pass this dictionary JSON schema extra keyword. Okay, so there will be strict validation here. Yeah, this is not gonna work, right? If I just so I can move this. So I can run this, but I don't think those fields are saved. Let's see. Oh, come on. So the module, what do I have here? Oh shit, sorry, module. Okay, next, module. Field. Did I write solution depends on itself? No, solution does depend on it. So module, what, the time complexity? No. What is this? Module. Okay, I really need to strip this. Let me run that again. Oh, come on. Okay, so field, yeah, I lost the thingies here. So this is not good at all, right? Because we lost our depends on field. Okay, so we need to look at what the heck is a DSPy output field, because it's a pydantic field. But pydantic doesn't allow arbitrary arguments to be given to fields. It only wants description. If description in quarks for quarks to do if DSPy field arg names. Okay, so DSPy field arg names. The following argument is if I'm a field in addition to standard pydantic field. We just hope pydantic doesn't add these. Okay, so this is how DSPy does it. Okay, so we need we need to inject our fields here. So I think we're just gonna write new fields, right? So pydantic field. I see, so we need to make sure that pydantic doesn't have a depends on field. Because probably doesn't. If we're to copy DSPy's way. And we'll just make our new fields, and then our new move quarks will extend this, but with... Damn, this is a constant. This can be monkey patched. Oh, let's see. Let me try to see how to monkey patch a Python variable for a single class definition. Anti-pattern. Okay, we do not want to do this, right? Yeah, we can fiddle with this, but interesting. So we need to get here, but DSPy hard codes this. I guess it's better we copy code then, right? So we're gonna have to write our own move quarks. And pydantic just wants JSON schema extra, so we'll copy over our new field, which is a whole complex field in itself, but it's fine. What do we have for constraints? Pydantic constraints. Yeah, we're not touching this, right? Greater than, okay, we don't want to touch that. Okay, so then we can do our own output fields, and we'll have to wrap, okay. And then what? Because this doesn't tell me what the heck is going on, because the module is predict, which is just a module. What does this guy do with the fields? It has a thing called adapters, I think. I may be wrong though. Maybe not. Or is it in predict? Yeah, okay. So the forward model gets the adapter. Actually, this is useful to stop here because I'm not familiar with what the heck this is doing. So let's see what is the default adapter for predict. What is settings.adapter? None, because we didn't pass anything. So it's chat adapter. Okay. What the heck is settings? Can I just pass this? Oh, I see. From DSPy set. Oh, okay. So is this a global thing? Yeah, it is a global thing. Yeah, settings, LM, adapter, none. Okay, so I can set, what was this? So I can do, so I can do, sorry, DSPy adapters. Oh yeah, I just configured DSPy with an adapter. Okay, chat adapter in this case. All right, so let's see how the chat adapter, good. So let's see how the chat adapter uses the fields. Signature, okay. So when you call the adapter, it sees the signature. Perfect, and this already has the fields in it. We're getting close, so then we have to write custom fields and probably a custom adapter, which extends the chat adapter. Interesting. Do I have a super here? Base adapter class. Call. Execute the adapter pipeline. Format inputs. Process signature. Inputs. This is what we need to extend. This is the model call. Okay. It's the format method, right? Here it is. Oh no, this converts the DSPy structure belonging to Fuchsia exam conversations to multi-turn messages. So where do I use history field name messages? No, this is too low level. It's got to be the pre-process, right? Tool call output field name. Here it is for name field. Oh no, this is just a signature though. Okay, well I have to stop here because I'm a bit confused what's happening here. So who is templating the prompt for me? Okay, I'm stopped. So we are using the super. Okay, so we're not using the JSON. Huh, interesting. So what the heck is signature? Well, this should be my signature. Okay, what is processed signature? Well, I lost the fields, but assuming we had those fields, process signature is not too different, okay? And inputs is what? Oh, yeah. Okay, so this is the whole message, right? Your input fields are. Where do I want my instructions to go then? Where do we want our custom thingies to go? They should go in the end, right? So let's see if I, oh shit. If I print, oh no, I can't print the inputs. Well, do I have one of those history thingies? I do. So we would like our custom instructions to go here. Do we? Because these are kind of interesting. So the LLM will see these as the latest. I think we do. I think these are important enough, or at least for an agent. Yeah, let's put them here. Okay. So who writes the part that says in adhering to this structure? I think this is pretty easy to find if we search for yeah, it's not. So who writes the adhering part? Oh, here it is. In adhering to this structure, your objective is you are an expert in solving so this is what are we looking at here? So this is inputs, right? Yeah, length of inputs is what? These are all the messages, 2. Okay, so it's inputs of 0 is the system message, okay. And it's just content, right? Inputs of 0, content. Yeah, okay. So this guy write, and where the heck does this guy write this from? Where does the word adhering appear? Because if I can find that, interestingly, it's not here. Aha, okay. It is the chat adapter. I see, so it's format task. Aha, so here it is, system message. Okay, there we go. So format task description signature. Aha, so do we want... Okay, so for this to be modular, we would like another thingy here called format field interactions or output field interactions, right? Yeah, that's what we want. I see, and then he goes with the demos. Okay, so yeah, we're gonna inject this in the system message. Okay, so it's the format method of the base adapter, which is also the format method. Does this guy have a format? It does not have a format, right? Yeah. Nope, okay, good. So we need to override the format method. We can leave these as they are. All right, let's start our thingy now. So we can do, whoops, what the heck did I do? I don't know. So let's custom adapter that injects instructions about cross output dependencies. Okay, okay, gotta quit this. So then we can have our thingy here. So class let's call it file adapter. And it's just DSPy adapter. Or is it chat adapter? Let's inherit from chat adapter. Yeah, that seems a lot better. Okay, so we know we need to... Okay, so we need to override let's see. Okay, so we have to do some imports here from DSPy import signature from typing import any. Okay, we don't need all this doc string. We have to leave the method unchanged and signature conversation history. Here's where we want to inject ourselves. So let's not inject ourselves before the test. Let's inject ourselves just here. Okay, so we want a thingy here, which is self dot format output interactions from the signature, which will have the graph because we write it here. What the heck is split message content? Oh, is this from the, did I copy this? Oh, see, I copied it from the base adapter, that's why. Okay, well, I guess I have to import this, right, from DSPy base, split message, content for custom types. Okay, good, so now we inject ourselves here. We need to write this method now, which is a new method. So it's called format output interactions. It takes as input self and the signature. I don't even know why they type it like this. Well, I guess, oh, I see, because it's a class. They work with the class directly, and it does something. What does it do? What do these format thingies do? Oh, actually, that's a good question. What do they return? Oh, I see. They all return strings. Yeah, that makes sense, because this is all a prompt, right? Okay, so we definitely need this to return a stringy. Okay, so return, reuse stuff. Good. Now if I just do this, so now we need to look into the signature fields and use the graph we just passed. Which we'll have to talk about later. This looks pretty bad. Feels like we can do a data class here. Yeah, this should be a data class. Depends on. Dictionary is fine because it forces. Yeah, we want an unordered. Like the graph is unordered, right? We want a dictionary is fine for depends on. Okay, so let's see how one of these guys uses the fields from the signature. So when I call this, where am I here? Do I have the process signature or the signature? Who calls format? It's the so-called processed signature. What the heck is a process signature? We don't have native function calling. Self-use native function calling. Whether to enable native function calling when else for it. Through the adapter automatic configure function calling inputs contains the DSPy tool. I see. Okay, so this is some agentic stuff. We're not there yet. But we don't care because these are input fields, so we should never collide here. Okay. What else is this pre-process? Handle custom that use native response. This seems relevant. Native response types. Default native response types, citations. So what, they have a special field, citations extracted from an LM. Okay, I see, so it's a citation output field. What? Why would they delete? Oh, I see. Do they delete this because it's experimental, or what the heck is happening here, dude? I've never seen this one. Handle custom types that use native response. I think we're just gonna have to punt on this. I don't know what this is. Why would you delete it from the signature? Doesn't the model become blind to it, or? Oh, it's Anthropic Citation API. Okay, I don't know what this is. This looks horrible. What the heck is Anthropic Citations API? What? Citations, you have to pass this in the request. I've never used this. Yeah, okay. Provide documents. Oh, I see. So you still need to pass them as input. Okay, so this is like what, RAG thing? Okay, this looks like abandonware. Maybe. Claude, Citations, API, Reddit. Yeah, this is, I don't know if this is. Well, this looks important for code though, so I kind of don't want to just steamroll over it. But also it seems they deleted from the signature. List of updates should be handled by native LM features rather than adapter parsing. Okay, so DSPy citations can be populated directly by citation APIs. Okay, so this is... I see. So list of updates should be handled by native LM features rather than adapt. Okay. So then I see. So this is just for API stuff. If the model responds with special fields in the over the internet, then that's a whole separate response. So you don't want that in the signature. Okay. I think we're good. Everything we do will be, we want all the outputs. Yeah, we're not, unless in the future, maybe providers come with special code outputs, which is pretty funny because that's actually threatening DSPy itself, right? Okay, so we know we got the thingy here. So how do we use the, we were looking at how to use the signature. Well, it's gonna be the modified signature, but then we found out it's really nothing. Where was I here? Base adapter, right? Yeah, so the process signature is actually, so we don't have native function tool calling. Even if we did, it only affects the, yeah, so you can't have output fields here. Well, no, you can have, but this should be fine. And then for hello customer, okay, and then so this will just be the signature for us. Okay, so this is pretty basic. And finally going back, so we have the inputs, so it goes to self.format. Okay, we can ditch this one. Self.format, which now enters here, blah, blah, blah. So how do we access? So then I just need to see how one of these guys uses the signature. For example, field structure. We have the signatures. How do I reach into signature fields? So there's this small utility here. Format signature fields for instructions. Given a list of, a dictionary of fields. Okay. Signature dot input fields. So let's stop here then. Okay, so how do I, now I can configure DSPy LM, and what was it? Adapter, or was it? File adapter, like this? I think this is how you set an adapter, right? Yeah, configure adapter, okay. So you need an instance of the class. All right, I'm gonna take a short break here. We'll be back. All right, this is looking pretty good. So let's see. So we have a custom adapter. What was I looking at? Oh yeah, I wanted to run this. So we set it. And okay, so it should breakpoint right here now. UV run main. There we go. So we are actually right where we want to be. Signature should be intact. Okay, so now I enter this thingy here, and what do I have? Signature.output fields, it's called, right? Yep, okay. So we go like this. For let's to do, don't process these in topological order. So interestingly enough now, if the user writes the fields in a bad order, we're just gonna write them, we're just gonna write the reuse statements in that order. But I don't think you want to do this. The right way to do this would be to actually sort that for the user. But that also opens up the chance to resort the signature itself. So even better, resort the signature itself in the adapter, because we just saw a signature getting pre-processed and it was happening right here. Where the heck was it? Oh, base. Yeah, okay. In self.call preprocess. So this, yeah, now that we have dependencies in the signature outputs, we should respect the user order up to topological order. I think that's a nice graph problem, and that should be pretty fast. It won't hamper. Okay, good. But for now, we're gonna process these in order, right? So we're gonna say for output in signature output fields, okay. And we can get depends on is, what do we have in the field? Let's see, signature dot output. So needs, this is gonna need an order dict. But for now, we'll process them in the order of appearance of keys in a Python dictionary, which is that deterministic? That's a good question. So Python order of keys in dictionary. Okay, so it is insertion order in 3.7, at least according to AI, which everybody here likes. So that should be good. Okay, so then we have signature dot output fields. For example, one of them is solution, which is a field info. And from here we want JSON schema extra. And we are going to want dot get, what do we call it? Depends on none, right? There we go. So then we can get for field and info in signature output fields dot items, depends on will be yep. So this is a field info, right? Do I need to annotate this? I kind of do want to annotate this. Okay, so let me do it this way then. So info, which is a field info, will be, because this is kind of freaky, all right? So let's just go by key then. And what the heck is this field info here? The reason why I do this is because I want to have access. Oh, interesting, it's not here. Field info. Oh, I see. Here it is. So field info. Oh, it's a pydantic field. Okay, gotcha. So this is basic pydantic thingy. Okay, so now we have the field info, and depends on, okay, if depends on so the output will be return output. We're gonna have to write new lines here, right? So if the field has something, if the field depends on something, then we're gonna have to generate instructions, right? So for each dependent, right? So okay. So then it's easier if I'm so dumb now because I don't need the user. Okay, this is good. So we actually don't need the user to tell me where everything is found at in the dependencies. We just need found at, perfect. For each field. Okay. So then depends on just becomes a list. Oh, a set would be nicer. Nah, let's keep it a list. There we go. So found that. Okay. So this is drastically more simple now, because I don't need to specify things quadratically. And I made a mistake already because, so now I'm gonna need found that for everybody, right? So we know that the solution is found in the core directory. Good. We know that these are found in measurements. Same here. And this guy is also found in the core directory, but they depend on three things. Solution, time complexity. So now we can also cache the use statements, which is pretty nice. We don't have to generate the quadratic number of use statements. We just need to generate use statements now for each output field. And that's it. So let's do this, right? So use statements is now a dict. The output, okay, the output message, cache use statements for each output field, because we don't want to regenerate use statements every time. We'll probably need a generate use statement and a mini, actually we can have this be an inline function. Helper function that generates a language dependent use statement. Now this one is pretty tricky because use statement, this one is pretty tricky actually because, yeah, this is very tricky. I don't know how to do this generically, so I'm tempted to call it module name. But the thing is, in my mind, field name is aliased with a Python module name. Yeah, so this will have to be language dependent. From. So it has a field name and a location and the language. This works for Python, for Rust, maybe for C includes. It should, yeah. So it'll be something like from location slash or dot field name import interesting. I have to do it star in Python. So if language dot lower is Python, we know how to do this. Else we're gonna have to raise a use statement, or we'll have to raise an error here because I don't know. This seems brutal to write. This is probably easy with AI. Yeah, for Rust you can do create things. For C you can include C files. Yeah, there's probably a way. The star is sketchy though. But no, it has to work. No. It has to work because then the AI will... Oh, I see. But then, wait a second. Aha. So this is, okay. The AI will figure out what to do here. So maybe I can write this. Yeah, so it should be like this, because this goes in the prompt, right? So you want the AI because, oh, I see why, because the AI, so okay. So we're doing multiple outputs in the DSPy module. So all these things get generated at once. So however the AI decides to call the function, you don't, I mean, you can do, no, you can't do interventional decoding over APIs. So you have to let the AI figure out by itself. And then you want a placeholder like this, actually. This is exactly what you want. I gotta figure out this location thing, which is also sketchy in Python. You need a base location, right? So this should be relative to base. So the language will be Python. Well, actually, I don't need defaults for these. So location should be relative. Is there a path? Is there a way I can get? Let's see. Pathlib get location relative to path. Oh, it is relative to? Oh, okay, it is. Well, never mind. So that's exactly what I want then, right? And let's see, how do I import this in Python? So Python import by knowing relative path. So I have to go dot so hang on. So the use statement. So can pathlib give me parents too? Including parent up. Walk up true. Okay, so I need it with walk up equals true, right? Okay. Yes. But then do I need a quadratic number of I think I do need a quadratic number of generate use statements, because it's not only the It's if I'm in a Python submodule. I guess we have to instrument the whole Python module, so we have to write an init file. Okay, let's leave it like this for now. To do, so let's leave a to do. So use path relative to walk up equals true to get a complete and correct import. Okay. Note, alternatively, instrument and submodules. This feels way too complicated for this type of adapter though. Maybe, I guess for this, as long as the language is the same for all the fields, maybe you want the adapter to do this. Maybe not, yeah. Okay, otherwise if it's not Python, not yet implemented for language. Okay. So cache. Okay, so we can, it's not for each output field, but we can still cache these for each pair of locations, right? Because sometimes we may, yeah, okay, so we can still cache these. Now we were here. Okay, so we have depends on, and we also have what else do we have? For each output field, we have found that. So this will be base location now. Okay, so base found that will be info.json schema extra get found that. This becomes a mandatory field now, and if it's missing, we can assume it's here, right? We gotta be careful with this one. It's a path. Yeah, I think this is sane enough, right? Yep, this should be sane enough for files. Okay, so if we depend on, okay, so we can just walk for dependency in depends on, generate use statements and instructions for each dependency. Okay, so for each dependency that depends on, location will be signature, output fields of the dependency, found that, same thing here. Okay, and use statement will be, which is just an str, will be generate the use statement for field name, the dependency, the location, the base location is found at, well, let me just call this base location then. Okay, and the language is very good here. So if dep dot language is not field dot language, we need to raise an error here. Cannot generate cross language use statements, right? This doesn't make sense. Okay, so then we can use either of these, right? So we'll use field.language. Okay, so then output will be to reuse the function maybe this is not the best way because we'll still have a quadratic number of prompts, right? Can we get away with a linear number of prompts? So we can index this with the field dep use statement. So let me cache this, else we can compute it and cache it. Okay. When generating code for field okay. Use the following imports. Okay, I know what it is here. So we don't want to, I see. So we want these to be introductory instructions, right? So if there's at least one dependency, then we're gonna add this to the output. And we're gonna start listing. Okay, so here we're actually gonna directly use the use statement. And that's it. Okay, so now we have a linear number. Well, it's still a quadratic number of instructions, but they're not that repeated, right? Yeah, linear would work, but well, it's a different philosophy, right? This one is more verbose because it tells the model to generate use statements from here to there, use exactly this. Otherwise, we could do this in linear number of instructions. We could just copy these paths. Maybe we'll add an option. Okay, so now we have format output interactions. This thingy here should be relative to base location. Walk up true. Let me try this pathlib thing. I'm kind of sketched out by this. So, do I have path here? Yeah, I do have path. Well, actually, let's do it clean then. Okay, the console is stuck, never mind. So I can just drop in a console, right? So I can do from pathlib import path, and I can do p1 will be path. Let's see. Stuff. No, it's some stuff. Oh, A. Okay, and then if I have P2, which is sum, and P3, which is just here. So now if I do P1 relative to P2, and I do walk up, okay, this is good. What is P2 relative to P1? Up, up. This is good, right? Because if I am in P1 and I need to use something from P2, oh boy, so this will be double dot in Python. All right, so I have to convert, yikes. Okay, so I may need some AI help here. So I wonder if there's a way to get these automated. This one's easy because okay, so all the slashes become dots. What about P4 is path sum code B. So then if I do P4 dot relative to P2 walk up. Oh no, because it's just code B, right? Oh, but I need to know, why don't I get... Yeah, so we need to figure out, this is not gonna be that easy, I think. I think it's looking a lot easier to instrument sub-modules, to be honest. Yeah, because here I already know I'm in Python, right? So then I just have to write an init.py file here, if it's not in this, in wherever I am, and that's it. Yeah, so can just write init.py at the current location. Okay, so that's all I need to turn it into a module. And then use an absolute import. Python modules, absolute import. Yeah, so I have my project, which is a solution folder. I have py files. Okay. So I just do import. Yeah, this should be fine, okay? So oh boy, I can't believe we have to go through this crap. This is fine. Why? So I can ensure that init exists there. No, we don't want relative imports. No. Yeah, I don't understand why this seems sane, right? Okay, so this example is busted because they forgot to put, okay. Yeah, so we'll just do init everywhere. And it's just from import sound or from sound import. Okay, yeah, so from solution so if I have both an effects.py folder or sub-package and a file, that's going to be a conflict, right? So from solution.test import oh, I see. So these are sub-modules. Very interesting, because what if this is the thing, when using from import, the item can be either a sub-module or some other name. But how the heck? Ah, I see. The import statement first tests whether the item, okay, this is how it is. So if not, the import statement first tests whether the item is defined in the package. We're not gonna have this because our inits are gonna be empty, okay? So I see, so we're not gonna expose any functions. We'll have empty inits. If not, it assumes it's a module. So we're only gonna do it with files, yeah. Okay, good. This is what we need. This is pretty easy then. Yep. So let's see. Yep. Yes, use. Okay. And then finally, let's not forget that we need a custom field class. Custom fields. Okay, so we're gonna need a output file field, which inherits from DSPy output field, but it will have to change its, what did we find here? What was it called? Oh. Is this even this is a function? Well, never mind. Okay. Yeah, it's a function. It's not even a class. Okay, so it'll just be a define. It doesn't even take args. Oh, it does take quargs. Okay, and it just returns pydantic. So pqrs import pydantic. No, actually pydantic is here. Okay. We're gonna need this move quargs function. Unfortunately, this is gonna have to be copied code. Yeah. Okay, so finally we got to this thingy here. So translate. So what is translate pydantic field? This one we can import, right? So from DSPy dot where am I here? Signatures field import translate pydantic field constraints, and finally custom fields that remain visible in pydantic. Custom field arg names. Good, finally we can use this, so we'll have to we'll just add to this guy, right? So from this, okay, and we just need to import this one too. Signatures.field import DSPy. Okay, plus finally, so what new fields do we need? Found that and depends on. Yes, depends on. Okay, so then we have the move quargs. We don't know. Well, we can keep this. And this is our custom field type, very important. It's output file field. And we just have to use this now. This is no longer an output field, it's an output file field. Whoops, not DSPy. And sorry, this should run now. Where the heck was the breakpoint? Well, let's see. It should be here. So I just have to run main. And there, the code should just stop, and I should see some custom instructions. They're gonna look messy. Those import statements are not good, but that seems fixable, albeit, did I forget to use the, interesting. Interesting because, sorry, what? What do I have in history? Yeah, nothing survived here, right? So this is 707. Yeah, this is now. Did I do the stupid signature again? Oh, no, this is my signature. Oh, no, this is good, yeah, because, oh no, but my instructions didn't go through. Huh, why does my adapter not go through? Eek. Let's stop here. Well, that means my adapter is not going through. Which I kind of thought it did though. Yeah, the adapter's not going through. Oh. What? If I change this back to output field, it is going through? Oh, don't tell me it has some validation thing or something, or what's happening here. Yeah, no, it's not. The code doesn't like us anymore because, our breakpoints are not going through at all. Why? Can I stop here? Like what adapter do I have? And what am I even running? Is this main PY and 02? Is it in part 2? It is. Okay, so I am here. So what module, what the heck kind of adapter does this guy have? It's a predict. What do I have? DSPy.settings. Okay, it's an adapter. So why doesn't predict hit my... Okay, so we have to take it this way then, right? Where was the adapter used? Oh, here it is. Okay. So I better see the adapter there, right? I'll tell you what's happening. The format... Right, so adapter, yeah, it is a file adapter, but then it just goes in the call method. So we did all this for nothing because the format, you would think the format is used though. Aha, so DSPy, I see. Okay, so I can't inherit, oh my God, okay, so because I inherit the call from here, It goes to the super call, which is but this is fine though, right? This is the adapter call. So what does this guy's call do? Okay. Very good. So what? Do I stop here? Is it the super and I don't... Oh my god, I know what's happening here. It's because it's using the method... Wow, this is so bad. It's using the method... Yeah, okay. So self.format is the method of adapter format, not... Yikes. Okay, I know what's happening. So so it's forcing it to call the format from the parent method because of the super here, and I inherit the super, which becomes a double super, right? Because our super is the chat adapter. How complicated is this call? Not at all. Let's just override it then, right? So we just need a call here. And that's it. So now it just has self.format. What the heck is LM? It's some type annotation, right? And this is on. Okay, this better be on. I don't know why. Okay. Good. So now we're gonna enter this. We will enter our post-processing. I think I forgot a breakpoint in predict, which I should really nuke. Yeah, I forgot a breakpoint here. We don't want this. And we don't want any breakpoints here either, right? Yeah, no breakpoints, no breakpoints. Okay. Check this out. This is gonna work now for sure. Good. So, very good. So I forgot. So I can't so we can early exit here, right? So if not depends on continue, then we know we have at least one dependency, and we can do introductory instructions. Okay, we're pretty much done here. Whoops. There we go. So let's see what system message. Let's just see what is our new what is this thingy then? Self-format signature. Oh, it's the empty string. Okay, all right. So signature output fields, right? Yeah. Why? Because I forgot to return. Am I not using strings right? So I'm supposed to hit this, right? For field. Oh, I know why. Nothing survived then. Yeah, okay. So my custom fields didn't survive then. My custom quarks here in the signature found that and depends on. Okay, interesting, because I swear I had custom field arg names. So what? My Pydantic schema quarks. My Pydantic quarks JSON schema extra doesn't have the two fields I asked for? Okay. $154. Oh my god, because sorry, my bad. I forgot I switched back to the output fields because I was debugging the thing. We're all good. Gotta use the new fields we created, output file fields, obviously. There we go. All right, this should really be it now. So now I should have extensible prompt minus, of course, correct use statements, but that's a problem for another time. Okay, so field info has no attribute get. Okay, good. I'm very close now because this is why I wanted this, because I don't know what this info is. Here it is, dot. It's .json schema extra. There we go. That's a fix, because that's where the Pydantic thingy puts them. We're very close, very close. What? I don't have language here? Oh yeah, because the field is a key, obviously. So it's signature output fields, dep, and field, right? Yeah, I'm pretty sure that's how it is. Is it still a schema? Or is it still a field there, or what's happening here? This is easy to fix. So what does this guy have? Dot. Yikes. Oh, come on. I lost the field now. Yeah, it seems like I have to look at annotation. Oh god, which is dot. Okay, so it's annotation dot language. Yeah, this should be. All right. I don't need this, sorry. Again with the language. Where? Here it is. Language. 116. Field.language. So I just gotta take this one, right? Yeah. Use statements. Gotta keep it in the cache. We're done now. System message. There it is. Okay, doesn't look too bad, right? So now we have instructions. Before the docstring, we have instructions that tell the model when generating code for time complexity, use the following import statements from other outputs from ... Now these are wrong But yeah, we have for each dependency, for each output field, we now automatically prompt the model to write relevant use statements by extending DSPy. Not too bad for 2 hours. Spent half an hour messing around with Windows. Also had our first chatter. Yeah, so next time we'll clean it up, and that's it for now. Pretty happy with this for 2 hours. Yeah, it is one of the sharper edges of DSPy. So next time we gotta clean it up, and we have to actually turn it into a proper Python file system. I don't think there's a way to do this like cross language. It would be wild, right? I mean, you can write generic instructions, you know, which just say generate proper use statements for the language, given that the file is at this location. That is probably powerful enough for frontier models, but not for this small one we're using. Yeah, so thanks for tuning in, and I'll see you next time.